The problem statement is given here. We infer the line is inclined to both the planes of projections. It is given line is inclined at 45 degrees to the VP. But what is the angle of inclination with HP? It's not given. Then how do we say it is inclined to both the planes of projections? Because the true length of the line is 50 millimeters and the top view measures only 40 millimeters. Top view is less than the true length. Therefore, the line must be inclined to the horizontal plane. In general, projection of a straight line inclined to both the planes looks like this. So referring this sketch, we need to draw the projections of the line CD. For that, first draw the XY line and then try to mark the point C, because the data about point C is given, which is 10 mm in front of VP and 15 mm above HP. Therefore, mark point C dash, that is a front view at a distance of 15 millimeters above XY. Definitely the top view of point C will come directly below C dash. Therefore, draw a perpendicular and below XY line mark a point C at a distance of 10 millimeters. So C dash and C corresponds to A dash and A, or it is analogous to A dash and A. The true angle of inclination of the line with VP is 45 degrees. We don't know what is the length of the front view because the line is inclined to both HP and VP. So in order to find what is the front view length, we assume initially the line is parallel to HP and inclined at an angle of 45 degrees to the VP. When the line is assumed to be parallel to HP, we can draw the true length on the top view. Therefore, through point C, draw a 45 degree line. So this 45 degree is phi, that is the angle of inclination of the line with VP. So on this phi angle line, we have point B2. Similarly, here we can obtain point D2 such that the distance C D2 is equal to 50 millimeters, which is nothing but the true length. Now we can draw the locus of D like locus of B, because not because definitely point D will lie on this line, but where exactly right now we don't know, but it is given top view is equal to 40 millimeters. So top view here is AB, and in the problem the top view is CD. We know the position of C. Suppose if you are able to locate point D, then we can join C and D and then complete the top view. So to know where point D is located, take 40 millimeters in your compass, cut an arc on the locus line and obtain point D, join CD, and the length is equal to 40 millimeters. So top view is completed. Now we want to draw the front view. And remember CD2 on the 45 degree line represents the true length of the line, or simply it is a top view of the line when it is assumed to be parallel to the HP. So CD2 is a top view assuming the line is parallel to HP. And what is its corresponding front view? Draw a perpendicular from D2, and that perpendicular from D2 intersects the horizontal through C dash at the point D2 dash. So C dash D2 dash is the front view of the line when it is assumed to be parallel to HP and inclined at an angle of 45 degrees to the VP. So this C D2 dash is similar to A dash B2 dash. It is the front view of the line when it is assumed to be parallel to HP and 45 degrees to the VP. So once this top view is completed, our next aim is to draw the front view. So front view is nothing but C dash D dash, like A dash B dash here. We know the position of C dash. where is this D dash? We don't know. The angle theta, which is nothing but the angle of inclination of the line with respect to HP, is also not given. And how to draw? We know. Front view, C dash D dash is equal to C dash D2 dash. So C dash D dash is equal to C dash D2 dash. So here this is C dash D2 dash. Length of the front view is identified now. We can measure C dash D2 dash. Definitely that is C dash D dash. But what is the orientation of the front view? Orientation in the sense, what is the angle of alpha? It is not given. So theta is not given, alpha is not given. But we know what is the length C dash D dash, which is equal to C dash D2 dash. Then how to draw? Look at the sketch. B dash is lying directly above B. Similarly, D dash will lie directly above D. Therefore, from D, draw a perpendicular. So, draw a perpendicular from D. Definitely on this line, point D dash will lie, but where is its position? We don't know right now. To locate D dash, take C dash D2 dash as radius in compass. Fix C dash as center. Draw an arc until it cuts the projector, and the intersection point is D dash. So now we know C dash and D dash, join them. This is the required front view. So we have located D dash. Here, instead of D dash, B dash is there. On the same horizontal line, B1 dash. Similarly, we can draw a horizontal through D dash, and that is the locus of D1 dash. So on this line, D1 dash will occur. Why we are drawing this locus? Because our aim is to find the true angle of inclination theta with HP. We know the true length is 50. And what is this A dash B1 dash? It is a front view of the line, assuming the line is parallel to VP and inclined at an angle theta to the HP. And in the problem statement, theta is not given, but true length is equal to 50, and C dash position is known. And definitely D1 dash will occur on this line. Therefore, take 50 millimeters in compass, join them, and that point is D1 dash. So C dash D1 dash represents the true length, which is equal to 50, and that angle is theta. If you measure, it gives 37, and this is alpha, the apparent angle of inclination, which is equal to 58. Now, this is apparent angle of inclination of the top view, which is equal to 62 degrees. So this completes the projection of the straight line as per the data given. Suppose if you want to check whether the projection is correct or wrong, what can we do is draw the top view corresponding to C dash D1 dash. So what is this C dash D1 dash? It is a front view of the line, assuming it is parallel to VP and inclined at an angle theta to the horizontal plane. So what is its corresponding top view? Draw a perpendicular from D1 dash, and it intersects the horizontal through C at D1. So what is this CD1? We know CD1 is equal to the top view CD. We already have drawn CD. So CD is equal to 40. Definitely CD1 must also be equal to 40. If we measure, it will be 40. So what can we do now is take CD1 as radius, fix C as center, draw an arc. Definitely it will pass through D. Definitely the arc will pass through D. If it passes through D, then the projection, what have you drawn, is correct. Thank you.